Hey guys! We're still in section 3.7. I'm now on page 298, and now we're going to talk about the zero product property. Now, as I said at the very beginning of all of this, the whole goal here was to solve quadratics, and so far we haven't actually solved the quadratic. So now we're going to talk about how do you actually solve a quadratic with all this factoring and stuff. So the zero product property, it's actually almost something like that's so basic, it's almost weird that we have a property for it, because you probably just kind of come up with it without even thinking twice. So basically this says, so for any real numbers a and b, if a times b equals 0, then a equals 0 or b equals 0. Okay, so let's break that down. If you're multiplying two things together and they equal 0, then one of them must be 0. That is something that's kind of, in some ways, intuitive to us just from all the equation solving that we've ever done. So for instance, looking at example 8 here, so this first one, 3 times x equals 0. What must x be? Well, x has to be 0, right? That's the only thing that makes sense. Now you could, of course, divide each side by 3 and then you'd still get that x equals 0. But the point is we have kind of this intuition on this. So now let's extend that idea to this example here. So this might look like it's something totally different, but it's really the same idea. So I just want you to kind of notice here. This is one thing times another thing. From a mathematical perspective, that's really how we see this. It just so happens that that first thing is x plus 3 and that second thing is x minus 1. Okay, so then what we have to say then is either this thing here has to equal 0 or this thing here has to equal 0. So set each part equal to 0. i.e., I have x plus 3 equals 0. So if x plus 3 equals 0, then what must x equal? Well, I can go ahead and solve it. So I get x equals negative 3. So that's one possibility. The other possibility would be that x minus 1 equals 0. And if x minus 1 equals 0, if I just add 1 to each side, I'd get that x equals 1. So here would be my two solutions for this equation. So this is using that zero product property. Okay, so just to build on this idea a little bit more. So now I've got C here. So now I've got these three things being multiplied together. So each one of them, you have to set them equal to 0 and solve. If you want to pause and then hit play when you're ready, go for it. So I have to have x minus 4 equals 0, or I have to have that x minus 3 equals 0, or I have to have the x plus 5 equals 0. So one of these things has to be true for this whole thing to equal 0. So my solutions here are x equals 4, x equals 3, and x equals negative 5. That's all I have to do for that. Okay, so now let's extend this to actual factoring. So these next three I have to factor. I'll do this next one with you. So I've got x squared plus 4x plus 3. How does that factor? So I've got x times x, two things that multiply to 3 but add to 4, so that would be 3 and 1. So now look at this, right? Now that I've set this up, this looks just like what I was doing before. So now I just have to find the two places where I can't speak, can I? X plus 3, where will x plus 3 equal 0? This will equal 0 when x equals negative 3. And where will x plus 1 equal 0? X plus 1 will equal 0 when x equals negative 1. So those are my two solutions. Okay, so now I want you to pause the video and do these two. Hit play when you're ready. Okay, so for E, this is x minus 5 and x plus 4. So my two solutions here would be x equals 5 or x equals negative 4. And then this last one, this would be x minus 6 times x plus 6. So this will be x equals 6 or x equals negative 6. So those are my two solutions there. Now, I just want to point out one thing before I go any farther. Notice the difference here. These all equal 0. That's why we're solving here, right? In the previous examples, what we were doing before, there was no equal sign, right? It was just factor this and that was that. So there's a difference, there's a very subtle difference between this type of problem and the ones on the next page. So I just want to make sure that you appreciate that. When these are equal to 0, then you have to solve them and you have to have x equals whatever. If they don't have that equal to 0, then you don't have to have x equals anything. Okay, so let's go to the next page. So now I want to go back to what we were talking about in the last section about how we can use quadratics how we can use quadratics to solve equations. So I want to make a little connection here. I've got First I want to know, how does x squared plus 3x plus 2 factor? If you want to pause and hit play when you're ready. So this factors as x plus 2 times x plus 1. That's how that would factor. Now what I want to do, I want to notice on this graph, what are the x-intercepts? So if I look on this graph, my x-intercept is here and here. So what are those points? Those points are -1, 0 and -2, 0. Do you see any connection between these and this? Yeah, so if you were to set this equal to 0, the x parts of this would be the solutions, right? So note the solution to so if I were to set this whole thing equal to 0, the solutions to it would be -1 or -2. So there's this whole connection with how this factors and finding your x-intercepts and all of that stuff. So there's always this connection between the graphs and the math and kind of how you look at everything. That's kind of what I wanted to point out here. Okay, so let's take a look at the next page. So what I want you to do is I want you to identify the x-intercepts, and then I want you to determine what equation have you solved by finding the x-intercepts. And then I want you to also note, how does the quadratic factor. So I'll do this first one with you. So my x-intercepts, so they are here and here. So I'll just note that. So these are 3, 0 and 1, 0. And so then the equation that I would have solved would be x squared minus 4x plus 3 equals 0. And the two solutions to this would be x equals 3 or x equals 1. So those are my solutions. Now, if I look at this and I want to factor this, this will factor as x minus 3 times x minus 1 equals 0. And I can see that these are the solutions. So this is what I'm trying to get you to connect here. So why don't you go ahead and try B, hit play when you're ready. Okay, so here are my x-intercepts. So let's see, this is 2, 0 and -1, 0. So then what equation have I solved? So I've got x squared minus x minus 2. If I set that equal to 0, my solutions should be x equals 2 or x equals -1. So now let's check that by factoring. So how does this factor? This will factor as x minus 2, x plus 1. So yes, these would be the solutions, right? So again, they're all connected. So now let's go to the next page. So this is a little bit of a concept extension here. So I have now intentionally given you two graphs that are not quadratic, and you can't necessarily factor these just by maybe looking at them. But what I want you to do now is find the x-intercepts and then kind of connecting the relationship we've seen between x-intercepts, solutions to equations, and how things factor. I want you to now answer the same questions and write out the factorization based off of the x-intercepts and kind of what you've learned so far. So you might have to look at the previous page to totally put this together, but hit play when you think you're ready. Okay, so here are my x-intercepts. So in this case, I have 3. So I have 2, 0, 0, 0, and -2, 0. So what equation have I solved by using the x-intercepts? So if I set x cubed minus 4x equal to 0, the solution should be x equals 2, x equals 0, and x equals -2. Now, let's see if that's true. Can I factor x cubed minus 4x? Well, I can actually, right? I could technically take out the GCF. So the GCF here is x. So this will be x squared minus 4. And this will totally factor as x times x minus 2 times x plus 2. So here you go. And there are your solutions to that equation. So they're all connected. Okay, so for this last one, so here are my x-intercepts. So my x-intercepts now are -1, 0, 1, 0, and 2, 0. So now I can say I've solved x cubed minus 2x squared minus x plus 2, if I set that equal to 0. And my solutions are negative 1, 1, and 2. So you can actually factor this by grouping. So if I were to factor it, so out of the first two terms I can factor out x squared. So that means x minus 2. And then out of the second two terms I'm actually just going to factor out 1 so that this becomes x minus 2. And so I guess we could set this equal to 0. It doesn't really matter. So now this is going to be x squared minus 1 times x minus 2. And now notice x squared minus 1, this will actually factor. We looked at this one earlier. So this is x minus 1, x plus 1, and x minus 2. So how would you make each one of these factors 0? You would make them 0 with 1, negative 1, or 2. So it all connects and it all works out. So I think that's a good place to leave off in this video, so I'll see you guys in the next one.